Hey everyone, welcome back to episode 2 of our HashiCorp Vault series. In this video, we are taking a deep dive into Kubernetes Authentication. We will break down step by step how pods running inside a Kubernetes cluster can request and retrieve secrets from Vault without hardcoding a single password or token in a secure manner. Let's start with a classic problem every DevOps or cloud engineer having. Your application running inside a Kubernetes pod needs to connect to a PostgreSQL server or database. Where do you put that database password? You cannot put it in the pod's YAML manifest. Anyone with read access to the cluster could see it. You definitely should not commit it to Git or GitHub, and baking it into the Docker image is a massive security misconfiguration. So how do we solve this? The core question is, how can an application prove its identity to Vault without possessing any long-lived credential in advance? Today, we are going under the hood to see the exact authentication flow that makes zero trust secrets retrieval possible in Kubernetes. So in episode 1, we learned that Vault uses three main pillars: auth method, roles, and ACL policies to deliver secrets. But we skipped one vital step. How does Vault know the application is not lying about who it is? Let's trace how Vault uses Kubernetes native security feature to verify identity. So in step 1 begins when Kubernetes creates your pod. Kubernetes automatically mounts a service account token, a signed JSON web token or JWT, directly into the container at /var/secrets/kubernetes.io/service account/token. Think of this token as an official passport or ID card issued directly by the Kubernetes control plane. So in step 2, the application reads that mounted JWT and sends a simple HTTP post request to Vault endpoint. Notice what is inside this payload: just two things, the JWT and the Vault role name it wants to assume. Notice what is missing: no hard-coded Vault tokens, password, or master secrets. Step 3 is where the magic happens. Vault does not just blindly trust the incoming JWT. Instead, Vault calls the Kubernetes API server using the TokenReview API and asks, "Hey, is this JWT legitimate?" Kubernetes checks the cryptographic signature, checks if the token is active, and verifies the service account name and namespace. If everything checks out, Kubernetes gives Vault a green light. Once Vault knows the pod is genuine, it moves to the step 4, role mapping. Vault inspects the configured role, for instance, payment-role. It verifies whether the caller's service account and namespace match what the role permits. If the caller matches the payment-SA in the production namespace, Vault prepares to issue access. In step 5 and 6, Vault generates a short-lived Vault token linked directly to the payment-policy ACL and returns it to the application. The application then presents this Vault token back to the Vault to read its specific database password or API keys. Everything follows the principle of least privilege. To bring it all together, pod starts and receive its secrets account JWT from Kubernetes. App sends the JWT and role name to Vault. Vault checks the JWT with the Kubernetes TokenReview API. Vault validates the role, namespace and service account requirement. Vault issues a short-lived Vault token, and then application reads secrets using the Vault token. This entire cryptographic dance happens in just a few milliseconds on startup. So in real production environment, you don't even need to write code to handle this logic loop or login loop. Instead, you use a Vault agent sidecar container. This Vault agent runs alongside your app container, handles the Kubernetes login, automatically renews the token, and seamlessly delivers the secrets to your app. To recap what we learned today, Service Account gives Kubernetes workload a native identity. Vault uses the Token Review API to cryptographically verify those identities. Roles tie Kubernetes namespace and service account to Vault policies. Zero long-lived credentials are needed or stored anywhere in your cluster. So that wraps up Kubernetes authentication. In episode 3, we will explore Vault AppRole authentication, the standard way to secure application running outside Kubernetes, such as virtual machine, CI/CD pipeline, and legacy servers. If you found this breakdown helpful, hit that like button, subscribe to the channel, and I will see you in the next video. Thank you.